part 1. Gentlemen, you took that experiment about the livers and fulcrum. Is that right? Now you took that term, which is called by a torque. Alaykum salam. Can you explain for me or describe what is a torque? What the word torque actually represents? I know that Doran, Azim Doran. I need. What is it?
The net sum force is 0.
Net sum force is 0. It's related to the force, but it's not the force yet, Zaid. Yes, Em?
Rotation.
Yeah, it's related to the rotation. That's good. Okay, who else? Give me something more. Okay, see. Torque, by the way, is a term that is related to the force. How? We have the force, the effective force, alaykum salam. Alaykum salam. The effective force can be simply sorted into 2 kinds. There's a translational effect of the force, and there's rotational effect of the force. What this means, ya shabab, the force could simply change the position of an object. You just simply pull or push the object. Okay, that's simple. Let me show you something. This is a chair. Now, if I pull this chair from here to here, this is a translational effect. Okay? If I do this now, if I do that here to this chair, what is this? Rotational effect. Okay? Now this is actually what we call by the effect of the force. So, at the beginning, torque is simply the rotational effect of the force. That is always related to the force. That's why in Arabic I prefer always to say it's called the azm al-quwwa. وليس العزم فقط. Okay, Shabab? This is why, because it's related to the force. And now, you took also, gentlemen, that this torque is given by the following formula. Tau, this is the simple tau, is nothing but F times D times sine theta. We took this in the lab, I think 1 or 2 weeks before.
Yeah.
Well, gentlemen, now F stands for the force. Again, always the torque produced by a force. If there is no force, there is no torque. Okay? Alaykum salam. Now D, gentlemen, is nothing but the distance from the fixed point. That fixed point mainly we call it by a pivot or hinge or a fixed point. النقطة الثابتة أو نقطة الارتكاز. Suppose this here, this is my pivot. And when you just pivot, some people when they split English, they said it's pivot. No, it's not pivot, it's pivot. Okay? Sometimes we call it by a hinge. You know the word hinge, what it means? فصالة يا شباب. Just like here, the hinge of the door. Or the fixed point. Fixed point, okay? All the same things here. Now, if I have a force here acting on this, yeah, the force, this is my D, gentlemen. This is my D. If I have a force here, this is also my D. Yeah. Not this bar, but this whole bit, from the force to the hinge or to the pivot. So again, gentlemen, we say that D is the distance from the point of action of the force to the pivot. I prefer to use the pivot because it's more actually common in that one. Here we say distance alaykum salam, of F from pivot. From pivot. Now, sine theta is the angle between F and D. Angle between these two. I will explain this now. So this is general. And the unit of torque, gentlemen, what is it?
N dot M.
N dot M, because it's a force times distance. By the way, sine theta is a number. It has no unit. So this is M, and this is M. So the unit of torque is in Newton times meter. In Newton times meter. Is that okay for you? You know, you have this one. Let's proceed. See it. Now, we have the learning objective, define the torque, simple gravity. We have a short video. If you have time, we go back to it. It won't open as usual. Okay, never mind. See it. Now, let's go back here. this person who pushing that chair, we said this is a translational effect of the force.
Yeah.
Because just like when we push, who's coming down? Gentlemen, we have two effects of the force. If you push or pull that chair, this is called translational effect of the force. أثر انتقالي يا شباب. إنك ينقل الجسم من مكان إلى آخر. Okay? Why? If you do that, this is what? Rotational effect. أثر دوراني. Make some rotations. Okay? So the idea is like that. We have two effects of the force. Either translational. Now the torque is simple, the rotational effect of the force. It's simply the rotation effect of the force. Now let's see what is given here. Now what is the rotation equivalent of the force? Because by the torque. The ability of the force to cause rotation depends on three factors. The force, gentlemen, the distance from the pivot, and
The angle.
let me tell you a story that we have. All of us, I think we saw this before. Sometimes you may saw this before. For truck drivers, if they have a problem with their tires, they want to replace the tire. This is a big tire like this. They face this problem. Sometimes the nuts, they will stuck. These nuts they have to replace. Okay? Or to unscrew it only. So yes, they use a spanner for this one. مفتاح يا شباب. When they put the spanner, as an example like this here, they push with their hands to open it. But you know that the wheels, they're walking on sand, dust, mud. So that's simply, that nut is stuck. He has two options. All of us, we saw this one. What is the option one?
Keep giving it
Yes,
force.
he step on it. When he step on it, what he's doing, he increase what?
The force.
Allah barik you. So the torque,
Increases.
this is the first one. He step on it. The second thing that we have it, he use Yusuf, other step on it. He tries to step. He's very, we can say, he's very, yes. He used another pipe for it. This one. This pipe, a taller pipe. If he use a taller pipe, actually he increase what?
Distance.
And of course the torque will. That's it down. So please, ya shabab, you should know the following here. We need to show you this idea. Torque mainly depends on force and distance. If the force increases, the torque will increase and distance here. Sometimes if the distance decreases, to keep the same torque, we have to increase what?
The force.
The force. And if the force decrease, to keep the same torque, we have to increase what?
The
Distance. This is, we have it. Now we will see some questions in these. That's by default. So you know that. Because that rotation, did you know that? The same person, he will unscrew this easily now. Because he used his, I can say, his nature. He step on it, he used his force of weight, and he used that pipe. Is actually, this is, we say we can gain this information by nature from each other. Is that okay? طيب يا شباب. Magnitude of the force, distance from the pivot, and the angle. Of course, about the angle I will talk about. Let's talk about the angle. See, if you have a spanner like this, and we have, this is a pivot, we apply a force here. As I told you, the distance from the force, this is here to the pivot. This is my D. I will call it R. By the way, R, D, S doesn't matter. It's same, it's just as simple. Now, if the force Z here, this force makes an angle with the axis.
Fine.
Yes. This is not a perpendicular angle. So the idea is what? In this way, we have to simply resolve the force into its components. We have a horizontal component and vertical component. Gentlemen, we took this before. The forces are vectors. If you have a vector with an angle inclined, you can just simply resolve it. تحلله. صح? You have horizontal and vertical, x component and y. So, gentlemen, what happened in this case? We have what we call by the horizontal component, let me call it f of x, and vertical component we call it by f of y. Okay, now see. Only who has a torque this one. Because this will cause a rotation.
Yes.
This one has no torque. And I will prove it for you now. I will show you now how is it. The torque, gentlemen, is equal FR sine theta, okay?
Yeah.
I told you theta is between F and R.
Yeah.
Now, F and R here, theta is 90.
Yeah.
So, when theta is 90, gentlemen, here, sine 90 is 1.
Yeah.
So, in this case, torque will be the maximum. Torque will be maximum, F times R. I will write here maximum, max. Because the maximum value of sine theta is 1.
Yeah.
Now, gentlemen, if we have here theta, this is 0. How it is 0?
Cosine
Because this
180.
one and this line, gentlemen, they are parallel on the same line, see? They are, we call it here as a parallel. So the angle between them is
Zero.
sine 0 is 0. So what about the torque?
Zero.
This case will be the minimum. The idea is what, Yashab? I will do this again for you. This is what we have it. We have a gentleman, if we have a force perpendicular, it's okay. We got the maximum torque because the maximum value of sine theta is 1. If we have a force with an angle, we have to resolve it. Always we take the vertical component, not the horizontal component. How is it? I will show you here an example. It's very simple, nothing there. And we can explain it simply. I'm sure that you took this before. See, Yashab. Suppose we have, this is a hinge, and we have the following forces. We have, say, this force 1, F1. We know this is here, and this is R1. Is that clear? And the direction of rotation here is counterclockwise, so we consider it to be positive. Clear? Now, that is what, if we have a force like this one, say F2, say this an angle theta. Theta could be any number, 30, 60, whatever, okay? What happened in this case? We need to resolve this. We have two components, one component here and one component.
Yeah.
This one I'm gonna call F2X for horizontal. And this one, okay, Yashra. Where's R now? R is this point. From here, I will do from here to here. Is that right?
Yes.
This is R2. Yeah, Shabab. R2 and F2X, how you just describe them? They are parallel or perpendicular? Yes, you see, this one and this one. They parallel. When say parallel, that means theta equals
Zero.
so the torque will be here, torque will be 0. We cancel this. Only this one has a torque. Only this. We take only, in other words, we always take the perpendicular or the vertical component. Y component. Right. Okay, Shabab? We don't, that X component has no effect on that one. Right. I have something, and I will explain. Is that clear for you? Right, Shabab. Now we go back here to the same graph. We can simply define the torque in two different ways. This is just an idea, not more than that. In first one, that what we take before, that the torque is equal to R times perpendicular force. This is the perpendicular force, this one, not this one, this parallel. So if you just watch, this one is like, it's F, see, just we write two lines. Two lines means parallel. This one, F, this one, it's perpendicular. Stands for perpendicular.
Yeah.
So this has a torque, this has no torque. Okay? So we say that, here we have the perpendicular force. Or, in another way, I will show you another option. That option, by the way, all of us, we are not using a lot, but it's an option. Mainly we use the first one. You can use that perpendicular distance. Leave the force, don't resolve it. Just keep it as it is. What happened? Take the extension of the force and make from the pivot a line that is, make an angle with that extension. It's easy, Shabab. If I say A is perpendicular to B, indeed, B is perpendicular also to A. Right, Shabab? Same thing. Now, this is R perpendicular. This is another description of. Mainly, we use the first one. We are not using this one. But you can do both, okay? Now, to make it more general for us, we have this one, that tau is equal to RF sine theta. And we know that, gentlemen, that we have it. Torque is measured in Newton meter. Okay, for you? I need just here to tell you something before we proceed. This is just one description. Always, gentlemen, that forces that is parallel or passing through the pivot, passing through pivot by any angle, has no torques. If I say, for example, this force is parallel, so sine theta is 0, tau is 0. What about this force? This force has a torque.
But it's on the pivot itself.
Yeah, so,
Zero.
because R is, Allah Barak Fik, right. If R is 0, so the whole term, so I see any force passing here from any direction,
Zero.
it's 0. This is put in your mind because we have this problem, we will have it later. Okay, let's proceed. You see some questions now. We know that torque is a vector. We have directions, right? We have clockwise and counterclockwise. Clockwise negative, counterclockwise is positive. Gentlemen, we have here 6 forces. I will number these forces for you. I will call this one here. This force 1, 2, 3, 4, 5, and 6. Who can tell me which of these 2 forces is the most or produce the maximum torque? Yes,
4? Oh,
4?
no, I mean 2.
2 and another one.
And 6, yeah.
Barakallah feek. 2 and 6, the maximum torque. Which one produced the 0 torque?
4 and
Wallahi man. Which one a partial torque would be 3 and?
5.
So please, ya shabab, be careful. That perpendicular is the maximum, and parallel is the minimum or the 0. And something between them with the angle will be between them. Okay, that, yeah. So this is not more than that. We will see some questions on these. Let's talk about the directions. Okay. The last point, I need to say something. If you have just like this road, subject to many forces, the total torque, gentlemen, net torque, just like the forces, resultant force, it will be the torque due to the force F1, and the torque due to the force, and blah, 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 to how many forces? And of course, you should take care of sign, positive or negative. Sometimes your net torque or resultant torque, it could be positive. That means rotation will be clockwise. If it is negative, rotation will be counter. That's it. So we deal the torque just like the forces. In previous example, we find the total force or the net force, right? The same manner, we will find what we call by the total or the net torque.
Isn't it opposite, yes?
Yeah, yeah. It is.
I'm talking about like.
I am sorry, yeah. This is counterclockwise, this clockwise, sorry. Okay? You got this, it's already mentioned here. طيب يا شباب, tell me, is there a problem that is clear?
Yeah.
Now we will see how is it clear for you. Go to the questions. Let's go. Who can answer the first question? Of course, when you answer the question, you have to justify it. This is the easy question. Yes, sir.
F1.
Right. Why?
Because it's
Yes, say. Perpendicular.
perpendicular, yes.
And what about F4? It's also perpendicular.
No,
But it's closer to the
Yes, barakallah. It's clear, gentlemen, that F1 has more torque than F4. Can I say that torque 1 is greater than torque 4? And also, this has no torque, so we skip it.
Yeah.
If we compare between 1 and the 3, which one has more torque?
1.
1 is perpendicular, this is by an angle. So torque 1 also is greater than torque 3. In general, this torque 1 will be the maximum torque, or the greatest torque.
Okay, if we compare about F3 and F4.
Nothing. F3 and F4, by the way, we should have the angle to know.
Yeah.
Because that's why he asks you something very, very particular, clear, okay? He will never ask you. But if they say which one has the least effective,
It's F2.
it's F2. This is 0. He will ask you one of these. This is okay question. Now, Take your time reading the question too and find it. Yes.
Choice D.
Why?
Because it's better.
It's parallel.
Yeah.
And we say if it's parallel, that means its torque is.
Zero.
But he.
No, he's
You
asking
read the
about the
question.
net torque.
Type. Let us read the question with each other, okay? Which third force on the wheel? This is two forces. Applied at point P. You should put it at point P. Up, right, left, whatever is it. Will make the net torque.
Zero.
Okay, a bit here. تعالوا. Pay attention. What about this force? It has a torque. Why?
Because it doesn't have distance.
Doesn't have, it's passed through the pivot. I told you here now. Right? So don't care about this force. This force is applied on in the pivot. يا شباب simply if you push on the hinge على الفصالة ضغط بيفتح الباب مش تضغط جيب ايش ما تضغط صح؟ Nothing there. I told you here this has no torque.
Yeah.
So we say now the wheel is subject to only one force. Which force?
This one.
طيب. What about the rotation, Yusuf? Clock or counter clock?
Counter.
يوسف طبعا صاحي معنا ولا نايم؟ طيب. Okay, it's positive torque, right? So, gentlemen, to make the net torque zero, Zaid, there must be a negative torque. Negative. Is that right?
Yeah.
Which one will produce a negative? D. D, by the way, I will explain it. D, by the way, Shrub has no torque. It passes through the pivot. You try to do this. You figure it out. Where it goes, up or down. You just push in this direction. D has no torque. This is wrong answer. I need somebody to understand it. I help you in this. Yes.
Choice D is D.
Yes.
Because,
I told you D is wrong.
No, no.
I think B.
A.
D? A. Yes. Say why.
Because in the A,
Yeah.
it have full distance.
Yes.
It have the distance with the double force.
MashaAllah. What is your name?
مش عارف.
You know, يا شباب, what Mishal, what he said? He's
Because
very smart, really, والله يا شباب. Really, sometimes, yeah, all of us we. You think that this question is not a tough question. Think, I will tell you what Mishal said exactly.
he did exactly.
See, يا شباب, he said this has no torque. Agree?
Yeah.
You just
Yeah.
Agree.
We said, suppose this is distance D. This is a force.
Yeah.
Now, this here to here, is it a D also?
Yeah.
No, it's shorter than this one.
Mm.
Say it's D over 2, half D.
Yeah.
I told you, if we lower the distance, what happened to the force?
Goes up.
Okay.
Which force is greater? It's
Yeah.
only A. This is the option, without even thinking. That's something, when you say something, you should convince yourself at the first step, right, ya shabab? I told you, I mean, when I explained this, I explained it here in purpose, for you to get the answer. If we control the torque by controlling distance or force, if distance decreases, the force should to get the same torque. Gentlemen, now let us imagine this gentleman, we put it here. تعالوا معي. Now this will cause a torque how? Negative, right?
Yes.
Now we say, for example, here 2F, I will say this is 2F, times D over 2, this will give me FD, which is tau. And this one FD, which is this tau, so this is negative and this is positive, they will cancel. Okay, is that clear?
Yeah.
واضح لكم? I will explain it again, then I will change the question. Because you see, a lot of questions and a lot of options. Ya Shabab, simple. Let's go back to the question. He asked you which force we should place it at point B such that the net torque will be. When you look at, I told you, any force passing through the pivot,
Zero.
so we have one force. Look, this force is at a distance, just name it by yourself, it's D. But here the distance is less than D. It's
Half.
suppose D is half. So the force should be greater than this. By the way, all of them is the same size. except,
A.
okay. Zay, if I change the point B to the circumference here, this is my B now, skip this one.
Yeah, okay.
Which is the option?
C.
See.
Barakallah. Right. You see how is it, ya shabab, simple?
Yeah, because it's the same distance.
Yes. And the I is what, ya shabab? We can simply shift the point B anywhere. We can do it, ya shabab, simple. Always control your torque by F and D. More force, less distance to keep the torque constant. Or the vice versa, العكس. Okay? Is that clear now for you, shabab?
Yes.
طيب. Now let's go to the next point. Okay. This is the second part. It's easy and we always done it before. What is the center of gravity, يا شباب? You took it before also. مركز الثقل. Center of gravity. I will call it like this. حليتوا معنا في الفالكروم أشياء زي هذه.
تكون مدخل في النص ما
It's not always the same, the middle point. Okay? طيب, let me explain. That center of gravity is the point in an object that look like the whole weight of the object
is balanced.
is concentrated or focused at that point. You can hold the object from that point, yeah, not from other point. For example, I will tell you something. Don't worry. I have this tablet. I can simply balance this tablet in my finger like that. You see, a little bit, right? Can I balance it from this point?
No.
So we can agree that the whole weight of this tablet is focused where? At that point. That's simple. We have it. All the objects, they have their what we call by the center of gravity. And they have their centers. Sometimes their centers, they are the same as the center of gravity. How? If we have a regularly shaped object, like this ruler as an example. You took this in the lab. This is the center and this is the center of gravity, right? Both the same point. If it is from 0 to 100, so the center point will be 50. There's no. Now, if you have a circle, this is our center of gravity, which is also the center. If we have a square, is that okay?
Yes.
Okay. If we have this rock, piece of rock, where is the center of gravity?
It's hard.
Now, this one here, we call by irregular. By the way, our bodies considered like this. We have irregular shaped.
Yes.
You are not squares, is it? You are not circles. You are not triangles, right? صحيح يا شباب? See, what is the idea? We split that our irregular object into parts, into segments, many segments. By the way, if you increase the number of segments, you will get more accurate values. So how we split? Well, we say consider this is 1, this is 2, 3, 4, 5. I give you an idea. We are not concerned about this, just only 7, 8, 9. Suppose we will find the center of gravity for each segment out of these, and then we add them up to find only one.
Center of gravity.
Yeah, for all of them. This is my center of gravity for all of them. As this point is a summation of all these. This is how the idea. Why we say that? Because our human body is irregularly shaped.
Yeah.
Gentlemen, we don't have the same heads shape. We don't have the same shoulders, the same legs, the same hand, right?
Yeah.
So what we say, we just split our human body into parts, segments. Head, neck, shoulders, right hand, left hand. You have your gut, you have your upper legs, lower legs, right? And find the center of gravity of every part of it. Then find the center of gravity as a whole, as a summation. This is the idea. And by the way, it's a very simple idea. So this is it. Now, one more point. If we have, gentlemen, here, regularly shaped object, always, as I said, center of gravity is nothing but the center. if we have an object like, for example, this is we call by baseball bat. You know that game baseball?
Yes.
This is its center. Where's the center of gravity now? Zay, tell me.
In the center.
Also the same?
Yeah,
No, it's there.
In the right.
And to the right
It's
here.
to the right.
Why?
Because the weight is,
The weight is
Allah is
higher.
right. This is what we said now. Always, Ya Shabab, the center of gravity is keep changing. And always is shift towards the heavier part of your object. Let me
Yeah.
say something for you. For adult people, the center of gravity is not your middle of your body, it's actually
It's below
lowered.
it, yeah.
Why? The idea is what? Because the tissue down here is much more intense, much more heavier than the upper one. Gentlemen, your legs is full up of muscles and very giant bones. While your chest is filled up with spongy tissue forming the lungs. That's a lot, right? يا شباب صدرك مملوء بالهواء فاضي. لكن أرجلك كلها عضلات من أولها لآخرها.
العضل ثقيل.
طب العضل ثقيل بالضبط. ايش بصير؟ That center of gravity will low. In case of babies,
It's up.
yeah, it's up due to his head, right? Sometimes when you hold something, yeah, Shabab, very heavy. See, if you hold something, you try to bend yourself,
Yeah.
you know, because your center of gravity is already shift. You try to manage with that one, right? This is, by the way, yeah, Shabab, all the athlete or sport people who's doing some gymnasium or some actions, they are so good in controlling their center of gravity. That's why they are doing that kind of sport. This is the idea, Shabab. So the center of gravity is not fixed, it's keep changing. If you hold this pencil case, center of gravity will change. If you actually bend yourself, center of gravity also will change. It's not fixed. Okay, ya Shabab? Let me tell you something here now. Of course, this is we need only to apply on the human body. Sorry. Now, let's talk about this. We have, gentlemen, here. This is a irregularly shaped object, right? We take the part segments and then we sum them up in one point. Okay? Now, the second point also, I need to tell you, an object that is free to rotate, I need to explain this one, about a pivot will come to rest with the center of gravity always below the pivot point. What this happens? See, suppose I have this ruler. This point is my center of gravity. You know that I can simply do this to the ruler. Is that right? You can do it simply.
Yeah.
Like this, okay?
Yeah.
Ya Shabab, if you just simply suspend that ruler and keep it free to rotate, see, hold it from one part, just release it. Always the center of gravity will be below the suspension point, below the hinge, below the pivot, always. It will never be like that. See, it should be always below. For example, when you just simply hold this here, it won't be like that. I cannot hold it like it. It should be below because the center of gravity should be below my hand. You got the point, ya Shabab? Anything that you have it always. Center of gravity is below the pivot or suspension point or the hinge. Always, ya Shabab. This is what I'm saying. In this case, this is the point. Also, center of gravity tends to lie closer to the heavier particles. We agree about this.
Yeah.
Center of gravity of an object is the point at which gravity can be considered to be acting. Right. Let's talk some questions on these. That's the idea. All of us just here, we prepare you for this. Only this is the last idea, and which is, by the way, it's very, very easy question. Gentlemen, we need what we call biomechanics branch of the center of gravity. This is the human being body. We, as we said, divide the human being body into segments.
Okay.
We know the mass of every segment there. For example, the chest here is 47 kilograms. This part of the hand is 2.2. This part is 1.3. This hand fingers is half kilo. You got the point? What is the idea, Shabab? What we do, all what we do, actually, we try to find coordinates for every point. For example, if we have here x and y axis, this y and this is x. If I ask you, what about this point? You say this is point, it has an x here and it has y here, right?
Yeah.
That's simple. We got. Okay, what about this point? You tell me, yeah, there is another coordinate. مش نقاط يا شباب, this one and
Yeah.
this one. Is that okay?
Yeah.
How we sum them up? We use a formula, gentlemen. That formula we use for x coordinate and for y,
Coordinate.
we say x1 m1 plus x2 m2 plus blah blah over m1 plus m2. This is for x. Finally, you get one number. And this is the same thing we apply for. We have y1 m1 plus y2 m2. Of course, I give only two parts. You can add even 100 over m1 plus m2 plus. Yeah, Shabab, nothing there. By the way, the mass is given for every part.
Yeah.
Yeah.
So m1, m2 is given. So you need to know the coordinates. You put, if you accept here, if you say this is 1, so this x1 is this one and y1. For this is 2, this x2 and this is,
1, 2.
and we gather them up. This is a very, very important question. And why is it? This will be given for you. All details. Your job was only to find the coordinates. Now let's go to the question. You got the question clearly. See, this is what is given. I'm sorry, Shab, I will solve the lower question, then we go up. خلينا نحل السؤال هذا. This is more related and important. See, Shab. Now in this example 714, gymnast performing on the ring holds himself in the bike position. Figure shows how we can consider his body made up of two segments whose masses and center of gravity positions are shown. Locate overall center of gravity of the gymnast. Gentlemen, we have 2 points. This point and this point.
Yeah.
This is the resultant. This is what you need to find. This you need to find. This point, let us call it. What is the mass of point 1? Shall I say M1 is 45.
Okay.
And Z, M2,
30.
okay. By the way, you don't have to write this, everything there. Your job is what? Find the coordinates of point 1 and point 2. تعالوا معي يا شباب. In point 1, the coordinates, I'm sorry, here, it's somewhere here and somewhere here.
Yeah.
By the way, I'm sure it's 15 and this one 50. 15,
So 50 over 15?
yes, and see, it's 15, comma, 50. Just, this is x1, this is y1. يعني.
Okay.
We use this in math, you remember? Yes.
Yeah.
Find the coordinates of point 2. يلا يا شباب, tell me.
30 and 20.
It's 30 and
20.
بارك الله فيك. 30. Is that clear?
Yeah.
Clear.
Let's apply the formula. Let's do it. Simple. Apply the formula. Let me show you. Now, according to the formula, Shabab, XCG, it's x1 m1 plus x2. Only 2 segments we have. You don't have to write. M1 plus. يلا يا شباب. How much x1?
It's 50.
M1.
45.
So 15 times 45 plus x2 30. You follow?
900.
تركزوا معي شباب. Over 45 plus 30. Okay?
Okay.
Let's go to the second point. YCG. It's Y1 M1 plus Y2 M2 over M1 plus how much Y1?
Y1 is
50
50.
times 45.
Yeah.
M1 doesn't change. Y2,
20 times the 30.
Mumtaz, perfect. Over,
Over 45 plus 30.
that's it, gentlemen. Finally, you'll find only 1 point. This one, gentlemen, it will become 21 centimeter, and this 38 centimeter. So you will come here at 21 and 38. This here, this is your center of gravity. You can apply this for the whole body, gentlemen. And instead of 2 segments, you can make it 10, 20 segments. In exam, you will have mostly 2 or 3. But this is the idea. Is that okay?
Okay.
Now the question is, before we proceed, is that clear for you, ya shabab?
Yes.
What, ya shabab? It's simple, Allah, it's a very good question. The idea is what? Here. We don't have, gentlemen, here to say, oh, we have only one figure. Do you know how many figures can give you? Infinite number. Some actually who's dance, making like this, who raises his hand, who raises his leg. Any figure, any action, we give you the coordinates, we give you the masses of the segments, and you just find the coordinates of every segment, finally the center of gravity, X and Y. That's it. Ya Shabab, I can give you infinite number of these figures, not only this one, not this position. Anyway, is that okay? So don't panic if you see another figure or another picture. It is the same idea. ما في يا شباب. Somebody, for example, somebody who's dance, raise his hand like this. I give you the figures, I give the segment, I give the coordinates. You just find the XCG and YCG. Yes, sir.
These questions, you will give us the, of course,
This
the
one and
and
everything.
coordinates, right?
Yes, of course,
And
coordinates.
coordinates. So, like you have to find the center. Is it given the center of gravity, and you have to calculate it?
You have to find the, you
Center.
can see the resultants of the gravity for horizontal, for and vertical. Like that, okay? And million, it will give you 2 or 3 segments. In real life, you apply for human body, which is about 20 or 50 segment. Never mind. But this is how we find it. When I say, for example, in my body, my center of gravity is here, because according to that calculation. Did you know, gentlemen, that bodybuilders, they shift their center of gravity upward because they have more intense here muscles in their shoulders. That's right. And sometimes, according to their body, I keep saying, your center of gravity is not fixed.
It's changing.
Yes, keep changing. When you bend yourself a little bit, Zaid, you just center of gravity change.
Yeah.
So if you have more muscles in your hand, change. If you have more muscles in your legs, also will change. This is how it works, okay? So don't think that my center of gravity is fixed. Fine. You got the point about this?
Yes.
Ya Shabab, he can give you any picture, any even real picture. Nothing. I will give you the coordinates, I will give you the masses of the segments, and you find the coordinates of the segment, then find the horizontal center of gravity and the vertical center of gravity. طيب, we done. This is the last example. يلا نبدأ في السؤال الأخير. Read the questions and we will draw it for you now here. Gentlemen, it's mentioned that a 1 meter long, this is the last point, dumbbell has a 10 kilogram mass on the left and 5 kilogram mass on the right. Okay? This is my dumbbell rod. Now, this is the center. Because he mentioned, this is, gentlemen, 50 centimeter, and this is 50 centimeter. Because it's all of it, how much? Now we keep this here 10 kilogram. On the other side, we keep 5 kilogram. Now this is the center.
No, it's
And that's center right. Where the center of gravity? Shift to the right or left?
Left.
Agree.
Yeah.
Yes. Suppose, let's say, this is my center of gravity. COG. Now, see what he's asking. Find the position of the center of gravity, the point where the dumbbell should be lifted in order to remain balanced. Okay? Now we will use, gentlemen, the formula. We use only XCG is equal x1 m1 plus x2 m2 over. Okay. Here, if you ask me why we don't use y, we don't have y, we have only horizontal. صح؟ تعالوا معي يا شباب. By the way, because I try here, sometimes this considers not there. Let here, this axis considers not there. You just set your own here, set your own figures. Now, I will consider this is 0 mark. So I will say this x1,
0.
what about this will be x2, which is 1 meter. Okay?
Yeah.
You can say, okay, can I put this 0? Yes, you can put this, and this will be?
One.
There's nothing about it. تعالوا نجاوب. See, that my center of gravity, gentlemen, is equal to x1, how much is it? 0. Times m1, so it's 0. Plus x2
One.
times,
Five.
so it's 5. Over 10 plus,
15.
it's 5 over,
15.
it's 1/3. So 1/3 is 0.33 meter.
Yeah.
Please, okay.
Left.
Where is the answer? It's either A or C.
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 دي
Why?
فيها تراك الأجوبة
أيوة.
لأنه يتكلم عن النص أبعد من النص مو من
Yeah.
طيب بارك الله فيك بارك. Thank you, Abhi. Thank you, clear. Yeah, see, but where's the trick in that question? يا شباب. We found this distance يا أخي. Because we consider this the reference. صح؟ طب see, he gave you here Z that this distance is 0.33.
Yeah.
Okay? Now this distance will be 0.17 because both of them, how much is it? 50. Okay? See the options. Let me tell you. The option is 0.33 from the 5 kilogram mass.
So from here.
That's wrong. صح? Now, it's 0.17 from the 10 kilogram. It's not from the 10, it's 0.33. So this is also wrong. We consider this is 0.33 from left to the center.
Oh yeah.
It is left to the center, but it's not 0.3. It's how much? So this is the option. You see, you score, you find it, oh, it's 0.33, yes. But sometimes, gentlemen, I will say how many options he can say. What is the center of gravity? Please, it's 0.33 right to 10 kilogram.
That's right.
Or, it's, gentlemen, it's 0.67 left to the 5 kilogram. How much this one? 0.67, right?
That's
Yeah.
Or it's 17 left to the center of gravity. All these. So the idea is perfect that please don't stick with the numbers. You should read the question. صح?
Yes.
Otherwise you will lose the mark.
Okay.
يعني أنا والله يا شباب all the students and this group very good والله compare مش عارف what's your name Ahmed?
Yeah.
They are good, so smart. They just really most of the students they said, oh sir, it's only C or A. No, it's not A. Read the question, you can figure it out how you solve it. Thank you يا شباب. شكرا.